We're back in Mr. Rice's garage again, and I did a few videos showing circuit analysis on the board, showing how to use the wireless breadboards to build circuits, and some of the technology of the board itself and how that works. And what I did notice was that my close-ups of the actual construction of the circuits didn't turn out so well, so I'm going to try to move the camera a little closer. Let's see if we can run past a couple of these circuit builds for the preliminary lab. For just learning how to hook circuits up to the series circuit resistor LED lab, 2 resistors in series with an LED, and let's see if we can get a little bit closer and show you how to wire those circuits up. Okay, so I'm going to get the camera a little closer this time. So again, Charlie's helping us out there with nap time still. And let's zoom in. Schematic up on the board showing a lamp. Again, the representation, electrical connection representation, not necessarily the physical wiring on the board, just showing the electrical connections. Lamp is hooked up, and then with the dotted lines, we're going to hook a buzzer up as well to the 9-volt battery supply. So let's try to zoom in a little closer. Let's see how this works. Hopefully this is just a little closer than last time. Okay, so per the lab procedure, we start by hooking up a buzzer or some device. I believe it said to hook up any connection in row 10. Remember, all of the holes in row 10 are electrically connected across, but they are not connected to the next rows, 11, 12, down to 15. We hook up negative side, the buzzer to row 15, one of the 5 holes available. Okay. Then we hook up a wire from row 10 from another hole of row 10. Remember, that is electrically connected to the red wire that goes to the buzzer, and we're going to connect that to the power bus, which is the column of holes that's connected. It has the red line beside it. And we're going to go with a blue wire and go from the negative bus, blue line, connected all the way down the board, right to row 15. So now the negative side of the power supply is connected to the black wire of the buzzer. Come in with our battery. Black wire in the battery is going to go to the blue bus. So it is connected to the wire electrically, to the blue wire. And then the red is going to go to the red side. So we have a complete connection, series circuit. Positive side of the battery, through the battery wire, down the red bus, power bus, across the red wire, to the red wire of this red jumper wire, to the red wire of the buzzer, through the buzzer, back to the black wire from the buzzer, across row 15, through the blue wire, to the blue bus, and back to the battery. One complete circuit. Current flows from conventional current from positive to negative, through and back. Electrons flow from negative, the blue side, and forward, electron flow. We could have easily hooked up another device, such as a light, low voltage light. Hook that in there to row 10. Show how that works. Hopefully quickly. Row 15, the other side. Push it in. Having a little bit of trouble with the light. Try to hold it in. And there we are. Light lights up. I explained about safety with light emitting diodes. They are not lamps, they are diodes, and they want to see a constant voltage across them of about 2 volts. So since they act like a voltage source or a constant voltage drop, if you hook a battery directly to an LED, you're going to burn it out, destroy it, because a device that wants to see 2 volts across it to work properly cannot be powered by a 9-volt supply without being destroyed. It's just too much voltage. So we have to put a series resistor to compensate for the voltage between 2 volts and 9 volts. So that we don't destroy the diode, we limit the currents and limit the voltage across it. So the instructions there say, with row 10, grab a 1K ohm resistor, start over with our circuit. One side of the resistor goes into a hole in row 10, the other side goes into row 15, like so. The LED, the longer side is the anode, the shorter side is the cathode. The anode is wired to the most positive part of the circuit. So the anode is going to be plugged in row 15 on that side of the resistor, and then the instructions say row 17 or 18 to plug the other side, the cathode. So I'm going to go down here to row, looks like 18. Again, the wire jumpers, connections from row 10, from another hole of row 10, the side of the resistor, into the red bus, the red electrical bus here, and then all the way down to row 18, next to the short lead of the diode, which is the cathode. In that row, plug in the blue wire. Doesn't have to be blue. Into the blue bus, holes that are all connected on the blue side, vertically, the edge of the board. Power, battery, black wire to the blue bus, red wire to the red, and the LED lights up. The LEDs come in a variety of colors and sizes and styles. Here's a small green one. Put that in. See that light up? And then we also have a more of a circuit board mount style. Between row 15 and row 18. See, that's a little green one. So for the series circuit lab, pull out the 1K, the 1000 ohm resistor. It calls for 2 330 ohm resistors. So I would start with the first one in row 10, simply. Just going to go ahead and leave that connection in, we're going to need it. And then the other end of that 330 ohm resistor down to row 15. Okay, it's a simple series circuit with resistor, diode, resistor, LED resistors. So 15, the LED goes to row 18, so I'm going to take the second 330 ohm resistor, plug it into another hole on row 18. Remember, that's electrically connected to the diode, to the cathode of the diode. I'm going to go down to row 25. So that's our series circuit. Going to complete that circuit by taking the blue wire from another hole on row 25, connect it over to the blue side, the blue bus, the vertical row of connections. Make sure the red one's on the red side. The red wire from the top of the first resistor. And battery, negative black wire to the blue bus. Red wire to the red bus. That's our complete circuit for the first series resistor LED lab. Take your voltage meter, turn it to 20 volts DC, That's DC voltage, not the other, not current, not AC voltage, not resistance or ohms. And part of the lab requires you to measure voltages across resistors, so take the actual leads to the meter. There's R2. Touch one lead to the metal lead on R2 on one side and the other. And we get about 3.6 volts on that one. So just across that resistor, not the entire circuit, that's still 9 volts. Just across R2 is 3.6 volts. Across R1, and about 3.5, so still about 3.6 volts there as well. There's also a part of the lab that talks about replacing the second resistor in the circuit, take the power off, with an unknown resistor. So I'm going to throw in a supposedly unknown resistor in there. Again, one side to row 18. And to complete that series circuit, the other side's got to go to row 25, because that's where my negative side of the circuit is hooked up to the battery. The blue wire. Re-energize the circuit. I now have 330 ohms. This way, conventional current flowing from the plus of the battery through this wire, through R1, through the diode, the LED, and then through the unknown resistor, that's the 330 ohm resistor, and then the unknown resistor there, and then back out through the blue, back to the negative side of the battery. Conventional current electron flow flows from negative to positive the other way. Measure the voltage across R1 so that we can calculate current, since we don't know the value of R2.